Good morning. Maybe it's morning. I don't know. It could be night for you. I don't know. It's morning for me. So I'm going to say good morning. And I'm tired. I'm really tired. I need to finish drinking my coffee so I can wake up and do all the things I got to do today. So, today we're going to talk about composite area. So, we're on page 28. Um, if you understood what we did 2 pages ago on page 26 with area, today is going to be so easy. In the real world, like, there are some things, like, we might see some rectangles and some triangles in some places, but the vast majority of things are multiple shapes put together, right? If you were to go out and buy property, well, sometimes you might get a nice square of property. Think of like the states, right? If you want to find the area of the state of Florida, Florida is not a nice, pretty shape that you could just be like, oh, just do the base times the height. No, you'd have to like make Florida into a bunch of different shapes and then do it from that, right? There's really only one state that you could do base times height, and I think that's Colorado. I think Colorado is a rectangle. Almost all the states and stuff, like anything in the real world, is going to be a large, weird combination of shapes, right? So that brings us to what we are talking about today. On page 28, we are talking about finding the area of composite figures. So the notes today aren't very, very extensive. It's just that you know what a composite figure is, right? A composite figure is just if you took multiple regular polygons and put them together, you get a composite figure. So like think about like if you were like 5 years old and you do a house, right? You just go like, there's a little square, and there's a triangle, right? If you were going to find the composite area of that house, you'd find the area of the triangle, find the area of the square, add them together. That's the area. So make sure you get that copied. I'll wait a second for you. I mean, you should pause it because I'm not really going to wait that long. I'm going to go on now. So hopefully you paused it and copied it. All right, so we're jumping into our first example today. So example 1. Example 1, and as always, I know I didn't do it in the last video, but I will put up the worked out versions of these from my notebook. That's a little bit nicer. Not that my notebook is very nice at all today. I didn't have whiteout when I did this, so I tried. It says find the area round to the nearest hundredth. Give me 2 seconds. I forgot to take my notes out so that I don't have to redo the math part of things. Right, I don't have a calculator in front of me, so. Okay, so it says find the area around to the nearest hundredth. You'll notice that we have 2 shapes over here, right? 2 distinct shapes separating that, and that was the nice way of doing it. Sometimes they'll give these pictures and they won't put like this line through them so you can clearly see where they divided at. They might just draw like like this, and you have to figure out yourself that you need to put the line right there to make it these 2 distinct shapes. If I look at this though, there's 2 things. The first thing that I noticed is this top shape right here, right? So we're going to look at that top shape first. I've got this like half circle, which we would refer to as, if you don't remember, a semicircle. And so for the semicircle, we're going to find the area of a regular circle, right? We're going to pretend it's a regular circle, but then at the end, since we want it to be a semicircle, we're going to take that number and we're going to cut it in half. So I've got 16 meters there. Notice that that length goes all the way across. So if I'm going to find the area of that, I'm going to have to be mindful of the fact that that is not the radius, right? That's the diameter. So the diameter is 16, which means to turn it into the radius, we just cut it in half, divided by 2. So 16 divided by 2 gives me 8. So I'm going to need that information in just a second to do that part. The next part we have to look at is this bottom part right here, which if we're pretending this is like an ice cream cone, because that's kind of what it looks like, right? It's the cone part of it. So I have 17 meters, 17 meters, and 16 meters. I run into a little problem here, because I know that to solve this part, I'm going to have to do base times height divided by 2. If you tell me the height is 17, right, the base here is clearly the flat part. The flat part is the 16 going across the top, and I'll put it across the bottom now to make it the base. Base doesn't have to be on the bottom, though, right? Base is just the surface that is the flat surface of the figure. So this is the base here, and then it goes up and comes back down, and the up and the down are each 17. But those are slanted, so that can't be the height. The height has to be this length right here, which I don't know. Which means if we're going to do that, we have to think about this triangle a little bit differently. Think about this. If this side's 17 and this side's 17 and this side comes straight down, well, then I know that I have two of the same triangle on either side, right? This triangle right here is the same as this triangle right here. So I know that I could focus on this being the height, this being 17. It came straight down and made a right angle here. And now I'm cutting this in half, so it's only 8, right? This is that dotted line from right here. That's that dotted line. So now I have half that triangle, and now I could figure out what the height is. We would use our Pythagorean theorem to do that. We would say a squared plus b squared has to equal c squared. In this case, c squared always is the side across from the 90, so it looks like they gave me 17 as c, which means I'm going to look for b. I'll use the 8 squared for a. I'm going to find b squared. So I square both those. I get 64 plus b squared equals 289. Subtract this 64 from both sides. Cancels, and I get b squared equals 225. I just went into my camera there. Let me just backtrack it. Hold please, hold please, hold please. Let's erase that here. Back here. Okay, sorry. Let me try that again. Okay, we'll come all the way over here. B squared equals 225. And then I could square root that, and if I did, I would find out that this height is 15? 15, yeah. So I know that this part here is 15. Okay, so now I actually have the information I need to solve this. Let's start again back up at this little semicircle that I started up here. We know to find the area of a circle, we're going to use pi r squared, right? But because it's a semicircle, we know that ultimately we're going to take that number and we're going to take half of it. So you can multiply by a half, you can divide by 2 at the end, whatever you want to do. But we're going to take the area of this circle and cut it in half to make it half a circle, because we only have half of a circle, not a whole circle. So if we just did pi r squared, it would be this entire circle, right? It would be if this came down and actually made a full circle down here, but it doesn't. It's just half, so we cut it in half. Okay, so we plug in what we have. We said the radius had to be 8. So with pi 8 squared divided by 2, you cannot divide the 8 by 2 first. You have to make sure you do the top first. So do 8 squared times pi, and then divide by 2. And if you did that, you would get 100.53. Make sure you actually use the pi button. But we're going to get 100.53. And since we know the units in this problem, it's going to be meters squared, since it's area. So we're going to hold on to that number. That's going to be important. Okay, we're going to come over now and we're going to look at the triangle. We know the area of a triangle is area equals 1/2 base times height, or base times height divided by 2. Again, however you want to look at it. I think on the actual notes I put 1/2 again. And we're going to plug in our stuff. So the base of the triangle, be mindful, the base of the triangle is this entire base over here. We're not looking at the half triangle, we want to look at the whole triangle. The base of the whole triangle is 16. And the height of the triangle is going to be the 15 that we just found. And we're going to divide that by 2. So again, we multiply that out, and this time we're going to end up with 120 meters squared. And now we can take those two things and we can actually solve this. Since we want to find the area of the entire composite figure, and since I now know the area of the circle, or the semicircle on top, is 100.53, and the area of the triangle cone on the bottom is 120. We're going to take those two things and just add them together. And if we do that, we get 220.53 meters squared. And that's the actual composite area of that little cone shape. So pretty easy. Like I said, if you understand your area stuff, this isn't going to be a problem at all. If you're comfortable with those areas, if you haven't memorized those area formulas, especially if you're watching these all in one day, right? Please make sure you memorize those. You have to have those memorized. Those should be things that just fire off the top of your head. If you see a circle, you should think pi r squared. If you see a triangle, you should think 1/2 base times height. If you see a square, base times height. If you see a kite or a rhombus, you should think diagonal 1 times diagonal 2 divided by 2. If you see a trapezoid, you should think base 1 plus base 2 divided by 2 times the height, right? Those should just be instant fire off things that you need to memorize. So please make sure you do that. Make flashcards, help yourself out. That way you know you're getting it. All right, let's look at the second example today. And the second example is a little bit different. And it says find the exact area of the shaded region. I didn't type the whole notes. So we want to find the area of the shaded region there. So again, thinking about what shapes we have. The first shape that I noticed is this nice little shape on the outside. And I didn't clarify, I probably should have when I wrote the example, but this is supposed to be a square. Actually, I don't need to clarify. There's a reason I didn't clarify, right? If there's a circle inside there, well, what I know is that from one side of the circle across, since it touches here, sorry. There you go. Since it touches both sides of this circle, I know that this to this is 25. Well, since it's a circle, I also know then the top down also has to be 25 because it's a circle, right? So it tells me that this shape right here has to be a square. And so we're just going to do our base times our height. 25 times 25, base times height. So we'll come to that in just a second. The other shape we've got to focus on is the fact that there is a shape inside. We have this circle inside, which we already talked about just now. Since it goes across, it's going to have a diameter. We're going to use our pi r squared, right? Pi r squared formula. The diameter going across is 25, and we know that that doesn't help us for this formula, right? Area of a circle uses the radius, not the diameter. This is where you got to be careful, because notice here that it said find the exact area. Since it says find the exact area, when you go to turn this into a radius, if you put 12.5, you're not doing it right. You're not allowed to have decimals in exact answers. They have to be all in fractions, all in terms of pi, all in radical form, no decimals at all. So I'm going to write the radius instead in its fraction form, 25 halves, 25 over 2, right? Don't actually do the math. You should do this entire thing without a calculator. Okay, so let's go ahead and work on this problem. So starting here, doing our area of a square, area equals 25 times 25, which means the area here, since it's in feet, is going to be 625 feet squared. Okay, so then we can go on and do the circle part. Circle, we know we have our area equals pi r squared, so we're going to have area equals pi times 25 halves squared. So when I go to square this fraction, you're going to square each part, right? You're going to square the 25 on top and get 625, and the 2 on the bottom and get 4. And then check if that simplifies, which it's not going to. The only thing that goes into 4 is 2, and 2 definitely doesn't go into 625 because it's odd. So I end up with 625 over 4 times pi. So we could simplify that by writing 625 pi over 4, right? We multiply the two things on top, these two together, and then leave the denominator as is. So now it's a matter of just kind of setting up this last step, right? In the last problem, we added the two things together, right? Because it was two shapes put together. This one's a little bit different, right? They started with a giant square, like a big thing of cookie dough rolled out. And then they took a circle and cut a circle and removed all of this white space right here, leaving just this little part right here. You can't really see the purple in there because it's already shaded, but we're just leaving this shaded part. So instead of adding this time, we're subtracting, right? We're removing something. We took the square and we removed the circle from it. So it's going to be a subtraction problem. So we're going to put the square first, subtract the circle from it, and then we'll put our units, feet squared. And that's the exact answer, right? It looks kind of ugly. 625 minus 625 pi over 4. It's really ugly, but that would be it. I mean, the only simplification you could do there is you could factor out the 625 if you wanted to, but then it's just going to make it longer and uglier and really doesn't help much. But that's it. If you wanted to find the actual rounded answer, you could put that in your calculator, but then we wouldn't be doing what they said. We wouldn't be finding the exact answer, so we would technically get it wrong. And that's it. So let me go ahead and put these notes up again. There is the examples worked out in my notebook, a little bit neater, a little bit nicer than me writing on my computer screen. Let me know if you have any questions. As always, you can contact me in my office hours or Discord or any of those things. Text me, all that stuff. Bye, y'all.